Hi folks, we're back at it again. In this lesson, we're going to look and see how you can use shadows in your knowledge of similar triangles in order to measure the height of an object. So in your packet now, I'm on page 16, which is where you should be. And let's go ahead and let's get started. If I start by reading that first paragraph, it says, when an object is outdoors, you can use shadows in order to estimate its height. And the diagram below is going to show you a little bit about how this is going to work. So for instance, on any sunny day, an upright object is going to cast a shadow. The diagram below shows two triangles. Here's what you need to be aware of and kind of pay attention to. The sun's rays, which are coming from down above, are always going to be parallel to one another. And why this is important is because the angle that they make with the ground will always be the same. Because objects are always going to be drawn perpendicular to the ground, they will make right angles. And now you should be able to see that these two triangles that are formed, one of which I just made red, and the other of which I just made blue, are going to be similar by angle-angle similarity. So the triangles are similar by angle-angle similarity. And this should look familiar because once the triangles are similar by angle-angle similarity, the sides are going to be proportional. The fact that it's really easy to measure the length of a shadow that's on the ground, but maybe not so easy to measure the height of a clock tower or the height of a tree, is going to be able or going to enable us to use the lengths of those shadows in order to measure the heights of the objects. So why does it work? Well, one of two different things is going to happen. Either we're going to have the objects standing kind of right next to each other and the sun coming in such a way that the ends of the shadows meet at the same point. And in this scenario, we still have two triangles. I'm going to think a larger triangle and a smaller triangle. Because the objects will always stand upright and make a right angle with the ground, and these two share an angle, those two triangles are going to be similar by angle-angle similarity. The other scenario that we might have is that the shadows are going to not meet at the same point, or they're going to be cast in different places. However, in this scenario, the objects are still going to be upright and make right angles. And because the sun's rays are coming down at exactly the same angle, those lines will still be parallel, meaning that the angle formed by the sun's rays and the ground are going to be congruent. And these triangles too, if I think about the triangles that are drawn in this picture, the blue one and the pink one, these triangles too are going to be similar by angle-angle similarity. So regardless of the scenario, whether the shadows meet at the same point, which is scenario 1, or the shadows are cast in different places, scenario 2, in either situation, the triangles are always similar by angle-angle similarity. And of course, once the triangles are similar by angle-angle similarity, we know that the lengths of the sides are proportional. All right, I know you're anxious, so let's go ahead and flip up to the top of page 17 and let's look at some problems or how we can solve some problems that involve shadows. So in the first one, it says we have this man who is 5 feet tall, he wants to find the height of a tree. At a certain time of the day, he measures his shadow on the ground to be 7 feet and the shadow on the ground of the tree to be 14 feet. They want us to find the height of the tree. Well, if you're clever and creative and a nice little artist here, you can draw some little pictures. I'm not such a good artist, but I'm in need of some fun. So I'm going to draw my man. Remember that the shadow is always going to be on the ground. My little man has a height of 5 feet. His shadow, which is going to fall on the ground, is 7 feet. And if I wanted to get super creative, here come the sun's rays to finish up that triangle. And now I've got a tree. So my tree is going to be a little bit taller than the man. All right, it's a sad looking tree, but you get the picture. This tree, we're trying to find its height. So I'm going to call that length x. His shadow is on the ground and his shadow is 14 feet. And remember that the rays of the sun for the tree are coming in at the same angle as the rays of the sun for the man, making these two angles down here where the shadow, or sorry, where the sunshine, the rays of the sun meet the ground, the same. So the triangles are similar by angle-angle similarity. And because the triangles are similar by angle-angle similarity, that means that the lengths of the corresponding sides must be proportional. So I'm going to go ahead and I'm going to set up a proportion in order to solve this problem. You know from the previous videos that I like doing the lengths of the small triangle over the lengths of the large triangle. So I'm going to do the left side of my little triangle, which is 5, over the left side of my larger triangle, x, is equal to the bottom side of my smaller triangle, 7, over the bottom side of my larger triangle, 14. And now that we've got our proportions set up, I'm going to cross it up. So 7 times x going in one direction equals 5 times 14 going in the other. And when I do 5 times 14 on my calculator tells me that's 70. So x, or the height of my tree, has to be 10 feet. Remember, when I set this problem up, I let x be the height of my tree. So once I solve for x, things are looking really good. All right, so that's a nice example of how we used the words in the problem to draw a picture. And in this picture, notice that our shadows were cast in 2 different places. Let's go ahead and let's look at the next example. This one says a tree that casts a shadow that's 20 feet long. Jake stands at a distance 12 feet from the base of the tree, such that the end of Jake's shadow meets the end of the tree's shadow. I'm going to grab my highlighter because those are some important words right there. That's what tells me the fact that the two shadows meet. That's what tells me that we're looking at the first scenario from the previous page where those shadows meet in the same place. That's important to know when setting up my picture. Jake is 6 feet tall. Determine and state the height of the tree to the nearest tenth of a foot. So again, I've got a tree. This one's going to be a little bit harder to draw, but here's my tree. There's its trunk. It's casting the shadow along the ground. Remember that shadows always go along the ground. So my tree is going to make a right angle. I'm trying to find the height of the tree, so I'm going to call that x. The length of the shadow for the tree is 20 feet. Jake stands at a distance 12 feet from the base of the tree, but what's important here is that the end of Jake's shadow is going to meet the end of the tree's shadow. So that end of the tree shadow is also going to be the end of Jake's shadow. So that means that our friend Jake here has to stand in between the tree and where those shadows meet. So Jake is 6 feet tall. His shadow, we don't know the length of, but we do know that Jake stands at a distance of 12 feet from the base of the tree. So we know that this distance from the base of the tree to where Jake stands is 12 feet. And if this entire distance is 20, and this piece of it from Jake to the tree is 12, we know that the length of Jake's shadow then has to be 8 feet. And once again, we've got this scenario where the two triangles sit one on top of the other. I like in that scenario taking the triangles and splitting them apart. So I'm going to split it apart into that large triangle and the smaller triangle. Remember, we've got the right angles where these objects are standing straight up. And then we've also got these shared angles here in the bottom right-hand corner. So our triangles are similar by angle-angle similarity, meaning that we can set up those proportions with the sides. But I'm going to go ahead and label my smaller triangles first. So in my little blue, or in my larger blue triangle, the left side of that is x. The length of the whole bottom is that entire 20 feet. In the orange triangle, we've got Jake, which is 6 feet tall for the left side, and then the bottom side, which is 8 feet. So again, I'm thinking similar triangles, proportional sides. I like doing the small triangle over the large triangle, so that's the way I'm going to go. So the left side of the small triangle is 6, left side of the big triangle is x, bottom side of the small triangle is 8, bottom side of the blue triangle or the larger triangle is 20. Once I get my proportions set up, I'm going to go ahead and cross multiply. So 8 times x is equal to 6 times 20. And then when I go through and do the algebra, x is equal to 15. Remember that in the picture, x represented this height of my beautiful, gorgeous, glorious tree here. So when I say that x is equal to 15, remember x really did represent the height of my tree. So 15 feet is the height of my tree. The other thing I need to be just a little bit careful of, maybe a lot careful of, is that they're asking me to round this to the nearest tenth. And when I did that answer, it didn't come out to the nearest tenth. So I'm going to put a 0.0 on there so that I follow directions and my answer is now rounded to the nearest tenth. As always, folks, thank you, thank you, thank you. Can't wait for the time when we're able to come back together again. But until then, keep on keeping on. You're moving in the forward direction. You're making progress. And I'm really proud of you.